All right, so we are live. Welcome to the Cool Data Project Show. I am Kristen Kerrer, a developer advocate for Comet, and this is the Cool Data Project Show where I interview practitioners in ML, DL, and AI about interesting projects that they're working on. And we all know that YOLOv8 just came out, just released very recently. And so my friend Peter from Roboflow has been doing a ton of work, and so with YOLOv8. And so we are very lucky today to be able to have him show us an actual live demo. So Peter, would you like to introduce yourself and tell us a little bit about Roboflow?
Hi, hello. So as it was already said, my name is Peter. I worked for several years as a computer vision engineer. And I joined quite recently the Roboflow team on a little bit different position than usual. I'm doing something called ML growth engineering, which is basically being kind of like a marketing person, but for developers. So, finally you have some people on the other side who actually know what you're talking about, which is pretty cool. And Roboflow itself is a company that is, I guess, most known for Roboflow Universe, which is kind of like the open source repository of data sets where you can share your data set or use work of others in your own projects. But we obviously do annotation tools, we do deployment of the models, remote model hosting, all sorts of stuff around computer vision. That basically reduces the boundary of entry for people who are not necessarily computer vision engineers, but they just simply need to use computer vision in their project. So that's more or less it. Yeah.
Yeah, no, awesome. Absolutely. Roboflow has been a big part of my being able to play with computer vision as a tabular data person historically. So would you like to tell us a little bit about the demo that you're going to be taking us through, and then we will just hop right into it?
Sure thing. So the demo itself is about tracking and counting objects, but we want to track and count with latest YOLO algorithm. Yeah, so we will be using YOLOv8, and we will be using Byte Tracker, which is one of the state-of-the-art trackers right now. And we'll be using one of the latest Roboflow children, which is Supervision. Basically yet unreleased library that we still working on, but we will be using it in that demo. And the goal of Supervision is basically to also reduce the amount of code that you need to write on a daily basis, because we want to create tools and utilities for computer vision engineers that they can just plug them in their project, and supposedly it just works. We still try to figure it out, but we will be using that today. Yeah.
All right, awesome. And so I think before this, we didn't go through how to share your screen, but you should be able to share your screen, and then I will add it to the screen. Yep.
Okay. Give me a second. I'll try to do it now. Yeah, okay. I know everything already. Okay. We should be fine. But yes, we didn't went through that previously, so that could be.
Yeah, so authentic, doing it on the fly. All right, awesome.
Cool. So should I start already?
Yep, take it away.
Okay. So yeah, one of the things that we do at Roboflow is do a lot of tutorials on a daily basis, and lately we've been producing a lot of stuff around YOLOv8, and most of those tutorials you can find at Roboflow GitHub repository in notebooks repo, which we launched like 2-3 months ago. And today we'll be using 2 notebooks from that repository to, first of all, I will show you how to use pre-trained model to track and count cars moving on the street. And, because Coco dataset contains classes like, track or car, we are on happy side of that training, and we can use it.
Hey, can you just make the text bigger?
Yeah, that's what I will be doing. I know that from my videos, so no worries. That was the plan. And okay, so that's the first thing that we'll be doing. And second of all, we will train our own model, because not every class is in Coco dataset. So if you would like to track and count something that is less popular than cars, and in our case that would be candies moving on a conveyor, we will also try to show you how to do that. Okay, so without further ado, I basically opened the notebook from our repository that is all about tracking and counting using YOLOv8, and we need to go through initial steps. So obviously, first of all, Google will ask us about that notebook. Are we sure that we want to run it? And then we run NVIDIA SMI, which is just to confirm that we have access to the GPU. And in our case, we have the access. It's Tesla T4. Then we run, a simple cell that is only here to help us to manage paths to data sets and to other things. And next, we will download a video. And the video that we are downloading, I can show you that video in the meantime, I hope. This is this video. So nothing very unusual. It's just cars moving on the street, and we will try to place some virtual line across that street to count how many cars moved in and out, basically. So that's what's happening over here. And yeah, fortunately that happened. So the video got downloaded. I will just create a small variable to have the path to that video later on, and we can move forward. Now we need to install Ultralytics, which is a little bit not intuitive, let's say, for some of the people. And that's basically the package that contains YOLOv8. This time the company decided to name the package with the name of the company. We are installing one of the latest version, 8.0.17. They are basically developing like all the way all time. So most likely it's already like 20 right now, but let's use this one. And now I'm using that time to install Byte Tracker. Like I said, we use YOLOv8, Byte Track, supervision combo. Byte Track is basically one of the most popular, I would say, trackers, and it doesn't use deep learning. It only uses IOUs, but still it's very efficient and works really well, especially in cases like that. So Byte Track is installed. I will just skip the stuff that I'm doing over here. It's a little bit, Byte Tracker is not the best packaged code in Python ever, basically. So we need to do a little bit of we need to help them out a little bit with our coding over here. And I'm installing supervision. So this is the library that I said we are using, and I will show you the things that supervision can do. So those are the imports that we'll use from supervision, and they range from everything. We have like utils that help you to load video frame by frame, utils that help you to save the video frame by frame. We have all sorts of annotators that help you annotate bounding boxes and lines and whatever you want. We try to have them all. Basically speaking, like I said, anything that computer vision engineer would most likely need in the project, we want to have it, and those are the utilities that we have already. Cool. Now let's load YOLOv8. So I will be using YOLO version X, which is one of the largest, but most likely we would be able to get away with smaller model, and we will try to do that in the second part of the video. So no worries, I'm not kind of like cheating over here and using the strongest model ever. And let's try to load that model into Notebook. Hopefully it works. Because Ultralytics is constantly doing changes.
Right?
So yeah, even loading stuff from the library sometimes, can be a little bit stressful, but it works. So now just a little bit of comment about the few cells over here. So obviously, Coco Dataset contains multiple classes, 80 classes in the basic format. We are only interested in 4 classes, and those classes are related to vehicles. Yeah. So if I take a look at the list of classes for Coco, you have plenty of different things, and we sometimes, as it happens in computer vision, even with pre-trained models, get accidental detections that are related to some classes that we are not interested in. In that case, primarily person is that detection, and those detections are only, like I said, like occasional and accidental. So the tracker may be a little bit throw of the main issue with those detections. So we will filter them out, and that's another functionality that supervision has. So as I said, we will be mostly interested in vehicles, so car, bus, truck. Those will be the classes that we are interested in. And if you take a look at those class ID list, those are the IDs that corresponds to those class names. Yeah. So I hope it's pretty straightforward. And now what I will be doing is we will perform kind of like the test detection for single frame, just to confirm that model loads properly and detects objects. So there, for now, no tracking, no counting, just detection on a single frame. But at the same time, you can notice that we use those utilities from a supervision library. So we use stuff that helps you to load single frame from the video, stuff that helps you to annotate the bounding boxes that comes from the detection model. So we are basically using supervision in all places over here. That code would be significantly longer if we wouldn't. And now I'm basically doing a test inference with that model. And, nothing really tremendous is happening over here. We got, I can make it a little bit smaller for a second. We got a single frame from the video. We got annotations, and we got the classes and the probabilities. So there's that. But now what we will be doing is we will run the whole video, and this time with tracking and accounting. And those things are plugged in a little bit lower. Maybe just a small comment, or maybe I will run it because it runs for a little bit of time, and I will comment in the meantime. So right now, the video is already processing. Things that we done is we selected the location of the line, which is maybe a little bit less interesting for this case, more interesting for the next case. But because we are doing that right now, I can describe what we are doing. So I basically so those axes over here helps you to understand where we located the line. So how axes are basically directed is from top to bottom and from left to right. That's how OpenCV works. So this is the pattern that we are using. And I selected the line to be located like somewhere over here in that area. So I'm starting from you can see I selected 1.5K, which is that height over here, and I start from left to bottom, left to right. So I started with coordinate 50, somewhere over here, and I'm ending with this weird number, which comes from the resolution of the video. So if you would take a look at the resolution, it's 38 by 40 by 2160, and that's how I selected the second location. Cool. And that processed in the meantime. You see TQDM loader over here, and in the meantime, I will start to download that video because Jupyter Notebook are notoriously slow at downloading the results. So I will do it in the meantime, and I will quickly go through the loop. I think that we will still have like a minute to chat in the meantime. So you can see I initiated by tracker over here. I initiated the video frame generator. which is, like I said, the util that loads frames one by one, and I initiated the line counter. All of that, a part of byte tracker, which is a separate package, comes from supervision library. And now,
can you tell us what the line counter is? What's the function of that?
What's the function of that? So line counter basically, so all of that movement over here. Let me just open that video once again, yeah, because it's much easier for me to describe over the video. So we will get detections from YOLOv8, typical stuff, bounding boxes, yeah. And now those things are moving, and we use tracker to know that objects on frame number 1 is the same as object on the frame number 2. Tracker has some logic that helps him or it to figure out what is what. So we will get a constant ID of the same object. So if that object has ID number 1 per se, on this frame, it will still have ID number 1. And this is how we know where objects are located on the video, not only on the single frame. Now, if we are interested in how many individual objects were traveling through that road, for example, or through any other space that is constantly monitored by the camera, we can do that. We can establish a virtual line and say, okay, if I see object on one side of the line at some frame, and then I see the same object, and I know it's the same object because it has the same tracker ID on frame that is coming later on in the video, line counter is picking that up, is, calculating whether or not the object is on one side of the line or on the other side of the line. And if that state is changing, we say, okay, that object crossed the line. And we also can monitor the direction of the line counter. So we can say it traveled in this direction or in the other direction. This is only line counter. We plan to add more counters to the library itself. So we will have something like zone counter, where we'll be able to tell you how many objects are in particular zone of the video. But it all will happen gradually. But this is kind of like the gist of how line counters work. And there are, all sorts of logic how you can calculate that it crossed, and we only implemented some part of that logic, but it's still a little bit of work to do that you don't need to do because of the library. We still have a lot of downloading to do. So either if you have more questions, we can go through those questions right now, or I can just show the result, but that would be a little bit, cheating. So I don't want to do that. I would much rather have the download finished. So if you have something,
let's not cheat. So so if somebody was looking to get into computer vision, how would you suggest they start, or are there certain resources that you think it would help them if they check those out?
So it's the question that I'm getting very often on Twitch streams, because everybody is asking basically the same question. So it all depends. If you are already software developer and you just want to switch, the topic of your work to computer vision for a change, or you are completely coming from outside of the software engineering per se, and just it's super cool to do computer vision. I would like to change my whole life and become computer vision engineer. Those things happens, but are significantly less probable if you are not coming from engineering background. So if I used to be civil engineer, so I used to be working on the construction side, but I went through the civil engineering studies, had linear algebra, all that stuff, and that was much easier for me. If I wouldn't have that is still possible, just less likely. But what I would like to suggest is, as always, I would say just have an idea for something that you want to do, and just try to do it. I still have my first Python project on my GitHub. It's a snake game.
Nice.
And when I look at that code after all that years, it's terrible. It's terrible. But that didn't matter back then. What matters is that you done it. It worked. You have the satisfaction from the fact that you managed to do it. Even though that when you started that project, it was like, I don't even know where to start. Basically, a pro tip: Google is a very good place to start. Learning anything. So if you just type in how to do snake game, you will find solutions on YouTube or on Google. If you type in YOLOv8 object detection, you will also find a good resources. I try to create those resources on a daily basis, so I hope you will find my tutorials. But that is the best thing that you can do. In my opinion, don't go on boot camps. Don't pay anybody money for teaching you how to code or do computer vision. Just Google that stuff. Go through free resources that are on GitHub and YouTube, and you will be fine. So that's my opinion.
Yeah, no, and I've definitely been checking out all your awesome YOLOv8 tutorials on YouTube. I was super impressed that, it was like they announced that YOLOv8 was available, and then it seemed like, the next day or two, you already had a couple tutorials up. So that
I can tell you that week I slept, like I barely slept. There was one tutorial that I even say that, guys, just like and subscribe because I slept like 2 hours. If you want me to continue with that lifestyle, I need to know that you are watching that. So it was pretty hard. The release week was pretty hard and harsh on my sleeping routine, but it is what it is. I expected that. I will take my days off at some point this year for sure. If Trevor, you are listening to that, you can expect that to happen.
Hi, Trevor. Did you experience any challenges that you can share working with the new library?
Mm-hmm. So I have for now I have a mixed relationship, like love-hate relationship with YOLOv8, honestly. So there are definitely things that I really like about YOLOv8, definitely things that I really kind of like looked forward to finally have in YOLO repositories, basically, because up until now we have the same structure. All YOLO repository had like separate scripts for training, detecting, exporting. That was really good like 5 years ago when, I don't know, YOLOv3, that was the first one that introduced that structure. And since then, everybody was just copying and pasting that structure. But me, as a computer vision engineer who deployed those models on production, this is not the structure that I expect. It is terrible to work with, like in real environment. So it's downloaded, by the way.
Like, how would you prefer it be structured?
PEEP package. That was something that I like, that I was dying for. Obviously, what computer vision engineers did is they forked the repository, restructured everything, and packaged that. Obviously, but then you have another problem. Anytime that YOLOv8, YOLOv5 or YOLOv7 team adds something new to the repository, that whole fork, all that work needs to be redone once again. So the moment that they actually support that internally and do release cycles, in synchronous way, so that everybody has access to that model in PEEP package, your life is like a lot easier. It's a lot easier. I know that many people are just using YOLO in the terminal. They just like YOLO detect, pass the path to video, and that's it. I know, but that's not what happens in the real life scenarios when you have like camera streaming. It's not like that. So PEEP package was something that I really expected, and I'm super happy that it is. The problem is that it's very immature. So my pro tip right now, if you want to use YOLOv8, wait wait like a month or maybe a little bit more than that, but at least month, because it's very unstable right now. Those jokes that I was doing, like I'm not sure it will go out. I mean, like it's life.
Like it wasn't a joke.
Taught me that lesson. Life taught me the lesson. So if I can just tell something to you, it's really cool tool. The model is training really fast, much fast. We done some benchmarks internally in Roboflow because we also care how fast is the training. Yeah, because for us, it's when you click the button train at Roboflow, we pay for that time of training on GPU. So the faster the model trains, obviously we save money. So we done some benchmark, and YOLOv8 is training really fast. So that's really cool for you, all of you, if you want to use that. But right now, really unstable. You can have clashing versions of models. So just wait. Okay. In the meantime, it downloaded. I opened the video, and that's what we see. So this is the line counter result. So you can see we start with this state. That car is not taken into consideration because it's already past the line. So we start with 0, 0. And now if we, can I do it with, I can do it like that. So when the whole car passes the line, it gets counted in. And right now we are counter 1. When another car is passing that line and the whole bounding box is behind the line, we count that as 2. And over there, I'm showing with my hand. Over there, if you do it, if you take a look at this car, when that car fully is on the other side of the line, it also gets counted in, just in another direction. And the same for the track, for example, over here, and so on and so on. You can have different strategies for counting. So you can, for example, have different strategy. Right now we say the whole bounding box needs to be on the other side of the line. You can have a strategy, and I've been doing that a lot in the past, where you select some anchor, like bottom, middle bottom of the bounding box, for example, needs to cross, and then it's counted in. So we will implement all those strategies in supervision. For now, I'm just showing you the strategy when the whole bounding box with the same ID is crossing the line. So for example, over here, not yet, but for example, now it's counted in. So that's how counting and tracking works. And you can also see like what I said, like the same car on different frame. We know that it's the same car. We have the same ID for the car on different frames. Yeah. So this is the demo number 1 that I wanted to show you. And I will, it's up to you. Do we want to go for demo number 2? I will try to be fast, but it's already 30 minutes in.
Yeah, I mean, I'd personally be interested to see it. And then actually I did have a quick question. So is this the line counting piece? Is this a lot easier in YOLOv8 now than it has been in previous libraries? I've never had to do it.
So first of all, it's quite easy because we implemented that for you. So you can just import that and just push the tensor that you get from YOLOv8, and we do like all the heavy lifting. Yeah. Is it easier? Partially it is. Why is that? So YOLO algorithm, generally speaking, has this system of anchors where if you would read the paper, actually, what is happening is that every frame gets kind of like divided into zones, like, for example, 7 by 7 or 11 by 11, something like that. And then you have some specific predefined shapes of objects that you can get from that zone. Why was that implemented in the first place? Because that was super fast. Like initially when YOLO went live, the paper, it was super fast solution. But since then, we get better ideas. And there is something called anchorless object detection. And anchorless object detections basically no longer makes you select from predefined set of bounding boxes that you can choose from. You can get any bounding box, any possibility, anything that is mathematically possible on that plane can be obtained. Yeah. And what is the outcome of that? Smoother detections. So something that you noticed in previous versions of YOLO is something called bounding box oscillation. So if you would take a look at 2 frames one by one, the object could get detected that is moving forward and then slightly backward and then forward once again. And that wasn't, because it was like shaking.
And the box would grow a little bit and it'd shrink a little bit.
Bounding boxes were shaking, were oscillating because of random reasons. Nobody knew. Yeah, it's very hard to know that. But it was all happening because you selected from some predefined set. And when algorithm had option A and option B, sometimes it selected option A, sometimes it selected option B because they were very close. But when you talk about line counting, like very small, if you want to only take into account one anchor, so a single mathematical point, it's very easy to get this oscillation, this situation where car would go in and out and in. And if you wouldn't go through a lot of hassle, smoothing of those coordinates, additional if statements that would, help you to prevent any accidental counts, it was very possible that with movement, smooth movement like that, you would get 2 in, 1 out, for example. So because you don't have, you have anchorless detector right now, you get smoother motion and it's much easier to count right now. You don't have this problem. And that problem was also, visible in other use case where you would do a speed estimation. So it's also possible to have, detector and tracker and estimate how fast that car is moving. Very easy. You just need to have a real life measurement and a pixel measurement on the frame. You convert that perspective and those measurements into kilometers or miles an hour, and you can calculate that. But because that car was constantly moving back and forth, that speed got even negative numbers in if you wouldn't correct for that.
Right. Touch the line, come back up, touch the line.
Exactly. So anchorless detectors, up until now, I guess only YOLOv8 was anchorless. And now YOLOv8 is also anchorless. And that is maybe not like solving all problems, but make those problems like less of a problem right now. So this is the key change, I guess, from the kind of like real life usage of the model.
Yeah, very cool. So I think maybe we shouldn't do the other demo today, and then we could always do another episode again where we go through that one.
I would be so happy to be, on another episode that for that reason only, I would preserve that.
Yeah, no, I think that'd be super cool. So let's see. So this demo that you've done, is this already a video that you've created that's on YouTube that people can go?
Yes, it's on YouTube. If you would, go into, YouTube itself and just search for Roboflow, there is a Roboflow channel that you can basically visit and learn from that channel. And also, like I said, if you are interested in the stuff that we do in that video, you not only can go to the YouTube itself, you just can start from that repository, go like, I'm interested in YOLOv8, for example, and then you will see like all tutorials that we have, starting from the code, and you can always go to our blog posts or our YouTube videos. So you can also kind of like search the other way around. So Roboflow Notebooks is a pretty cool place if you want to learn computer vision. That's how I would do it. And those videos are obviously here. So if you would go for object detection, here you can learn about object detection. This is our like quite recent video, the one that you said we released very fast. So it has like almost everything you need to know about object detection. At least I think so. So there's that.
Yeah, no, I mean, in my opinion, it's the best way to to play with YOLOv8. It's like, oh, we've launched this new algorithm. And then I went over and just played with one of your Google collabs, and it worked perfectly as expected. And
we do a lot. You know, I spend like 2 hours today fixing issues that people have. So trust me on that. I put a lot of effort and my private time into making sure that those notebooks works for you. And if they don't work for you, you know, you can always reach out in the issues on the GitHub, and I'm spending time making sure that it will work. So for sure.
Awesome. And then, so outside of YouTube, where can people find you if they want to follow you?
That's you know. So obviously, if we still talk about Roboflow, I write blogs on Roboflow official blog, so you can look for those things over there. I also have a GitHub account that, you know, I cherish more than anything. So if you want to find me there, you can find me at Skalski P. That's my nick over here. So this is my profile with this weird looking image, and you will be able to find all other things that I do from here. I used to do a lot of blogging back then on Medium. I almost have like 1 million reads right now. I'm just on the verge of crossing million. So if you want to help me
that's
out,
awesome. Congrats.
you can read my stuff over there. I'm doing Twitch streams from time to time where I solve computer vision competitions on Kaggle. So, you know, if you just want to spend time, you know, learning something about computer vision or helping me to learn from you, which is mostly what happens. I never remember how to do stuff, and people help me out over there. I'm also super happy to have you there. And yeah, from here you can get everything. You can latest posts, latest videos. And one more thing, one more child that I have is Make Sense, kind of like the open source version of Roboflow, kind of. Where basically back then when I was still at the university, created a JavaScript image annotation tool that, you know, a lot of people are used. Like I have like 2.5K stars, so that's pretty cool.
Oh, nice.
So you can use that too, you know. So plenty of options. Yeah.
Awesome. And then I just forgot what I was going to say, but we can link that GitHub in this LinkedIn post as well, and also put it on the Comet YouTube channel so that people are able to follow that.
That would be great. That would be great. You know, I had a dream of winning a GitHub star this year, but it may not happen. But I kind of like, if you feel that I'm doing useful stuff, you can always.
Yeah, guys, everybody, we need to give Peter some stars. And then, oh my God, I just forgot it again. What? Oh my God, what's my deal today? No,
I let you think, and I will just show the result for the second video. Like if people would like to see how you can do counting of candies, which is basically a pre-trained model that you need to train yourself, and you can still count other objects moving in different directions. That's the stuff that you missed today. So if you want to have a part 2 of that project, you know, you need to let Kristen know that, you know, it's something that we want, and you will have it.
Yes, no, absolutely. Let me know. And then, Peter, is there anything that you didn't get to say that you were hoping you could share with people?
Maybe one thing is that, like I said, we launched the supervision library, and we still look for ideas for things that we can have there. So if you have idea for something that is computer vision related, and you know, you need to write it, or you always need to rewrite that in every workplace that you work, let us know, because we are looking for those ideas for the API, and that would be tremendous help. even if you use that tutorial and you find something that could work differently or could work better, we look for the feedback from the community. So that's something that you can clearly do if you want us to write your code, basically, and not the other way around. Yeah, so.
All right, awesome. Well, thank you so much for joining me today, Peter. I thoroughly enjoyed watching your demo. I think this is the first time I've had somebody on the show that actually went through code. So that was super fun and interesting and exciting. And I look forward to our next episode where we talk about computer vision detecting candies.
Let's hope for that. And for about the live demo, work hard, play hard. Yeah. So it's significantly more stressful when you show the code that needs to run. So I understand others. I just decided to have a little bit of rush of adrenaline today. Yeah, exactly.
Alrighty. I hope everyone has an awesome day, and we will see you soon.
Thank you very much. Thanks for having me. Bye.
Thanks. Bye.